Hey, TechKnowSurge. You know, when a threat actor targets an organization, they're going to start looking for the way into the organization. What can they leverage to get into the organization? They're going to look at the attack surface, and they're going to look for attack vectors to get in. But what is an attack surface and an attack vector? Well, let's talk about the difference between those, and then talk about some common attack vectors. In this video, we're going to get into what an attack surface is, what an attack vector is, compare and contrast those two. We'll get into common attack vectors, and we're going to categorize them into three different categories: physical, digital, and human. And then we'll talk about the supply chain. We can think of the attack surface as all of the different ways combined of how we can get into an organization. I'm going to use this building as an example. Let's say we are trying to break into this building. We may be able to get through the front door, or perhaps we can tunnel into the building. Perhaps we can get through one of the windows. Maybe there's a rooftop access, or maybe we're going to break through a wall. But the attack surface of this building would be all of this together, all of the different ways that we could actually break into this building. The attack vector would be the specific way that we chose to break into it. So if we were to access this building through a window, then that would be our attack vector. If it's through the door, that would be the attack vector. Rooftop access, then that would be. Since we're talking about cybersecurity, let's apply this attack surface to our network and see what that looks like. We have a firewall right here, and that guards our network. And so what we have is an attack surface that looks a little like this. However, we also have this wireless signal that's right here. This is a wireless access point, and it broadcasts out a big signal. And so anything that's within that signal also has access to this network to a certain degree. So that extends our attack surface. To better understand the concept, I've broken down the attack surfaces into three different categories. We have the physical attack surface, we have the digital, and we have the human. The physical is what we've already talked about. Physically being able to access into the building, or perhaps it's into the network closet, or access to the equipment, wherever that equipment might be. And the problem is that if we have access into the building and break into the building, then what we could do is we could unplug somebody's computer and plug our own equipment into it, and now we have access to the resources on that network. We also have to consider the digital attack surface. There's information that's flowing in and out of this network. And since information flows in and out of this network, there might be a way to leverage some of that to get into this network. As an example, this wireless network just gets broadcasted out, that there's no way to really secure the waves from being able to reach anyone. And so if we were sitting out here, we'd be able to access, at least from a layer 1 and 2 standpoint, some of the information that's flowing. And so that's why it's really important to secure our wireless networks. Then there's the human side of this. People are physically walking in and out of that building and sitting down at these different machines. They're doing things like accessing their email. So if we can send them an email and leverage some social engineering to trick them to installing something on this machine, we now have access to the rest of the network and the resources on that network. And leveraging social engineering by sending an email and tricking somebody into downloading some sort of software onto that computer is an example of an attack vector. So within each of these attack surfaces, there are many different ways that we can trick or we can manipulate or change things as an attack vector to get into this network. Physically gaining access could be as simple as walking in the front door. Although what I've seen is that buildings have been more secure and more locked down than they ever have been before. So it may require some sort of social engineering, something like tailgating, to be able to gain access into the physical building. From a digital standpoint, we could leverage the network. One example might be is that we could sit outside the building and gain access to the wireless access points in the wireless network to try to leverage it to get into the rest of the network. Or perhaps we leverage some sort of hardware. Laptops might be brought in and out of that network, and when it's outside of the network, something malicious could happen to it that would be brought back into the network. For instance, we could install some sort of software on it. Software also gets installed and people want that on their machines, and so they'll do that. Or perhaps it's some sort of files that are being transferred back and forth. An attacker may use unsecured networks as a vector to get into the network. Perhaps it's the wireless network or the wired network, or perhaps it's something like a Bluetooth device that is connecting. Or there could be some open service ports. There are times when we open up holes in the firewall so that way they can get access to things like maybe a web server. Well, those are open ports on the firewall to gain access to the server, and there is a level of access to that server that might be able to be leveraged to gain access to the rest of the network. There's also hardware that gets installed on your network, whether it's a computer or a switch or server or some other device. And are you getting those from the proper vendor? So that could be a problem as well. Or just removable media. People taking flash drives and then random flash drives or other flash drives and then putting it onto their computer, which could carry a virus. An attacker may use software and files as a vector to gain access into an organization. Perhaps they're using some sort of vulnerability in already existing software, or perhaps there is some malicious software that they're tricking somebody into installing. A client-based would mean that it gets installed on the machine and runs on the machine. An agent-based doesn't need to be installed for it to be up and running on the machine. So we can take some of this malicious software and embed it into files, whether it's some sort of image or some sort of document. We can embed it so that way we can more easily trick somebody into installing that software. There's also unsupported systems and applications that get set up on a network. I've had people set up equipment, I've had people install software that cause problems on the network because they think that they want these extra services and don't want to go through IT, so they just install it and then that will cause problems. One of the problems is when this stuff gets installed, a lot of people will leave the default credentials. Well, that can mean that anybody can get onto that device and easily look up these default credentials to be able to gain access, therefore gaining access to the rest of the network and other resources. Then we have the human aspect of it, or the social engineering. Humans behave in certain patterns, and attackers know how to leverage those patterns to get what they want. Of course, to carry out a social engineering attack, there's got to be some sort of contact, and that contact could come in the form of some sort of message-based, like email or text messages or instant messaging, or it could be over the phone, some sort of voice conversation, or it could actually be in person. Now, I've included supply chain as its own category, but it really has roots in all of the other categories. But it's just one other aspect we need to keep in mind. So what is a supply chain? Well, a supply chain is all the goods and resources and everything that goes into creating a product. That's the general idea of what a supply chain is. But what does it look like when it comes to IT? When it comes to IT, supply chain is where we get our resources to provide our services. So we're buying hardware, we're buying software, we're buying cloud resources, we're buying services from other entities. We're buying this stuff so that way we can provide resources to our users. And so what we need to do is we need to keep that in mind, because if we're buying hardware, then there could be actually flaws in that hardware, vulnerabilities in that hardware, or even malicious stuff already installed in that hardware, or even the software, and utilizing the clouds. It's just one other aspect we need to consider, because it can be a vector for the attackers. So just a few things to call out, like one of the things is a managed service provider. A managed service provider provides some sort of services for us. For instance, maybe that service is help desk, and so they're providing our help desk services for it. Well, if they have problems within their organization and they're not being secure in the way that they're providing those services, that could be devastating to the rest of our organization. So when we're talking about supply chains, we're talking about the vendors and suppliers and cloud providers that are providing services for us. So what an attacker is going to do is they're going to look for their attack vector to get into the organization. And all those attack vectors combined makes the attack surface of the different ways they could get in. We talked about some of those attack vectors, the common attack vectors, and we categorized them into physical, digital, and human. And then we also talked about the supply chain, because we could have different vendors out there supplying different aspects that could be categorized in the physical, digital, or human as creating some sort of vulnerabilities for us. So it's one of those things that we need to make sure we keep in mind as we're analyzing our vendors and choosing our vendors.